What's up, scholars? Welcome back to the show. Today, we're going to be talking about some Pythagorean trig identities. I'm also going to go over the homework assignment from yesterday. So if you felt like you were like, I'm not really sure how to do all of this, we're going to go over those answers. So I'm giving away free answers. Yay! A couple of quick things. So, like, the video was talking about, you need to know your trig identities. You want to have these written down. These are the main three Pythagorean trig identities. Now, remember, these can also pop up in different forms, right? So if you see just cosine squared by itself, that is also going to be equal to 1 minus sine squared. So just remember, these can pop up in different ways. You can also change this number 1 to cosecant squared theta minus cotangent squared theta. So you never know. If you see some things, like, got to be able to kind of rewrite these a little bit. Also, let's just go over really quick what secant squared theta, cosecant squared theta, and cotangent squared theta are. Secant squared theta is 1 over cosine squared theta. And these are also all true for the non-squared version of these. So secant of theta is 1 over cosine theta. Same thing, just because the squaring properties work on both sides. If I were to square both sides, 1 squared doesn't change anything, and then I get cosine squared theta, and then over here secant squared theta, like that. So all of these can be either squared or not squared. Cotangent is cosine over sine. And just real quick, that comes from the tangent function. So tangent of theta is actually sine theta over cosine theta. And what we've done here, cotangent, is really 1 over tangent. And then, so if I say I'm going to divide this whole thing by 1, then I'm going to divide this whole thing by 1. And then recall, dividing by a number is the same as multiplying by its reciprocal. Let's say that one more time. Dividing by a number is the same as multiplying by its reciprocal. So this thing basically flips over and is just multiplied by 1. And then 1 times anything doesn't change anything, and that is how we get the cosine over the sine for the cotangent. Okay. So just kind of keep in mind, right, all of these things. So this one's pretty important, as well as these 3 are also important. So I'm going to keep these real handy as we go through the numbers. All right, so I don't know what order all of these questions were given to you in, but the first one that I saw on the quiz from yesterday was, what is the value of 2 sine theta cosine theta given that sine theta plus cosine theta all squared equals 1? All right, so this one's kind of nice. Recall that anything squared, this looks exactly like our quadratic equations, right? Like x plus 1 squared, that's going to be x plus 1 times x plus 1. Or anything squared is that thing times itself, right? So you know how to do this. You can either do the box method or the FOIL method. I'm not going to go over how to do that because you are like just champions at doing that by now. So I'm just going to do that really quick. Okay, so it doesn't really matter what order you wrote all of this stuff in. I just decided to put the sine squared theta and the cosine squared theta up front together, because boom, I have my first Pythagorean trig identity that I'm going to use. So sine squared theta plus cosine squared theta equals 1. And then if I subtract 1 from both sides, they're going to add to nothing. And then 2 sine theta cosine theta equals nothing. So the answer to this is the value of 2 sine theta cosine theta is 0, big fat 0. The second problem that I came across said to simplify. Now the trick on this one really is to recognize that these things in the denominators, each denominator, this is a difference of squares. Okay, difference of squares. Man, those things have just been popping up everywhere. These are a difference of squares. So like before, when we were factoring our things, right, difference of squares was like x squared minus 4, because 4 is really 2 squared. So this is a difference of 2 squares, right? So that's what we have here. So if I were to factor this thing, it would be x plus 2, x minus 2. So we're going to do that with this. We're going to go backwards. We're going to FOIL this out, and you will see that this turns into the first thing squared, 1 squared, which is just 1, minus the second thing squared. And I'm going to do on the same thing on the bottom. The first thing squared minus the second thing squared. And again, 1 squared is just 1. Nothing changed on the top yet. All right, so let's see, what do we got here? Here we are, 1 minus cosine squared theta. I'm just going to come up here. Notice I have a 1, I have a cosine squared theta, right? So this is really 1 minus cosine squared theta. That's going to equal sine squared theta. So this thing right here is sine squared theta. Oh my gosh, this is so beautiful. This is just anything divided by itself is going to equal 1. Love it. All right, over here, secant squared minus 1. I'm like thinking this is gonna do something over here. So secant squared minus 1. Oh, here we go. Secant squared is here. So this is going to be minus 1 gets me to tangent squared theta. So secant squared theta minus 1 is tangent theta. Tangent squared theta on the top. And these also cancel and just get me to 1. And a 1 minus 1 is, again, nothing. Oh my gosh, these, like if they all simplified to 0, like that would be really boring, right? Absolutely. Absolutely boring. Okay, so this one was really like difference of squares, but had you FOILed this out, you still would have gotten the difference of squares, and it still all would have simplified. Number 3 on my quiz, they're asking what is the value of cosine theta, and given that you have cotangent theta times cotangent, I still can't write, okay, cotangent theta plus sine theta equals cosecant squared theta. I am not a cosecant, I'm a cosecan. All right. So let's see here. I see cotangents. All right, I want cosine theta. So I'm going to look at my cotangent, right? And be like, oh, okay, because I got a bunch of cotangents. Like, okay, cotangent is cosine over sine. And cosecant is 1 over sine. So I'm just going to like, I'm also thinking about it here, right? Like it's also here, and this involves my cotangent. This one gets me to like a sine squared, which I don't really want sine. I'm looking for cosine. So I think I'm gonna try rewriting this one as this one instead of this one. Just because this gets me to cotangents, and I have cotangents out here. All right, so I'm gonna try this first. So this is 1 plus cotangent squared theta, and I really want things to cancel and go away, and I notice this one's like squared, so I'm going to distribute this and do the multiplication. Good. So now when I minus these from both sides, they are going to go away. Whew, that worked out. I was kind of nervous there. And then I'm just left with 1 equals cotangent sine theta. So what was the cotangent again? It's cosine. Yes, cosine over sine is the cotangent. So I'm going to take this one, cotangent, and I'm going to rewrite it as cosine over sine. Oh, so pretty. So now these sine thetas, they cancel. And I'm left with cosine theta equals 1. Well, I guess it's not 0. So there's that. All right, let's do number 4. And we got 2 to go. This one says simplify secant theta plus tan theta times secant theta minus tan theta. Oh my gosh. Do you notice anything? Anything pretty at all? Notice these are the same. There's a plus and a minus, and then these tan thetas are the same. This is a difference of squares again. It's glorious. It's glorious. So I can just straight jump to here if I can recognize that this is a difference of squares. And then this secant squared theta minus tangent squared theta, I'm going to rewrite the secant, and that is 1 over cosine squared. And then tangent, remember, is sine over cosine also. So I'm going to rewrite that as well. And now they have common denominators. So I'm going to rewrite this as a 1 fraction. One minus sine squared theta, that is here. This is, if I subtract sine squared theta from this, then I'm going to get cosine squared theta equals 1 minus sine squared theta. So this is cosine squared theta, and divided by cosine squared theta. And anything divided by itself, oops, can't really see. Anything divided by itself just equals 1. Kind of boring, but what are you going to do? And here we are on the last question. They want to know the value of secant squared theta, and given sine squared theta, tan squared theta, sine squared theta. Okay. Now this one, I'll admit, I look at this and go, oh my gosh, I cannot foresee what's going to happen. But let's just dive in here and start rewriting some stuff. You know, like rewriting tangent as sine over cosine, that's the first thing that I think of. But I realize that because sine is on top, I'm not going to be able to cancel these signs, right? It's just going to be like sine to the fourth. So that's weird. I do notice that both of these terms have a sine squared theta in them. So I'm going to try factoring out a sine squared theta and see what I get. Ooh, that's looking a lot better because tangent squared theta plus 1, right? Oh, it's right there. I don't even have to like move stuff around. This is secant squared theta. Oh, that's what we want. Okay, so tangent squared theta plus 1 is secant squared theta. And then to get this by itself, all I have to do is divide. And secant squared theta then equals, oh my gosh, pi over sine squared theta. It's like all of the answers up to this point have been 0 or 1, so this makes me very nervous. I'm just going to check and make sure that that is a possibility. Oh yeah, it's totally a possibility. Why do I doubt myself? Don't doubt yourself. Just go with it, right? So yeah, so there are the answers to yesterday's quizzes. Without knowing the difference of squares property, that's going to make things a little more difficult. Email me if you have any questions, and thanks for stopping by.